Right, take two. Good evening, Nix Vegas. I will be talking about the Nix Pipe Operator today. But before we get started, can I get a show of hands? How many of you here don't use Nix? Okay, that's nobody. That's good. And how many of you have had experience with some other functional language before Nix? I assume, like most of you, not me though. My first proper functional language experience was with Nix, and as you can imagine, all the parentheses, they are very scary. Right. So, who am I? You might know me on GitHub as illustris. I'm an Nix user since 2020. I'm one of the shepherds of the RFC 0148 that's trying to introduce the pipe operator. Right, so today's goal is to just introduce it to anybody who's not familiar with it and to sort of get people to engage in the RFC process and get that moving. Right, so the problem with Nix, or the problem I'm going to talk about with Nix is, well, you can see it right here, right? If I'm trying to figure out what this snippet of code does, I have to look all over the place. First, I have to find the object that it's operating on, which is my list, right? That's somewhere in the middle. It's in the middle to the right. Then I have to see, okay, it's applying built-ins.map on that, and then it's applying a filter, then it's applying built-ins.2json, right? So many, so you kind of have to look all over the place to try and figure out what this snippet is doing. Now, I used to write a lot of bash. I still do to a great extent, and I'm very much used to thinking left to right, pipe this to that to that. So this is kind of what the pipe operator will let you achieve. You've got your value, my list. It doesn't have to be a value. I mean, a function is also a value in Nix, I guess. But yeah, that value gets piped from one function to another. So you take my list, you do built-ins.map, x into 2, multiply it, then you do filter, greater than 5, 2JSON. Right? Same thing, much cleaner, much easier to follow. You can follow the flow of data from one function to another. Right, so how it works, the pipe operator, the way it is implemented right now, is vertical pipe, right angle bracket. There is also a converse left pipe operator, which is left angle bracket, vertical pipe. And what that does is it just makes the thing on the right flow to the thing on the left. Right, so let me show a less trivial example. This is an actual function from one of my flakes where I need to generate a list of subdirectories given a directory. So you do get subdirs // it should give me a list of absolute next door paths to all the subdirectories in a given directory. So implementation is this, and again you kind of have to look all over the place. P is the value that's being passed in, so now I have to look again to the center and to the right to see, okay, P is there, read div P, then filter attrs, then attr names, then map. Right? So this is what that would look like implemented with pipes. Much easier to read. I've got the same comments. It's just so much easier to just follow and understand what's going on. Now, some of you who really know Nix and Nix PKGs might say, but lib.pipe already exists. Why are you not just using that? So this is what the lib.pipe implementation would look like. Lib.pipe lets you do pipe, value, and then a list of functions to apply. But there are some limitations to that, such as, one sec. Right, so there are still extra brackets, parentheses. There are error messages which are a bit harder to deal with. It's not very discoverable. Like, I didn't know that lib.pipe existed until the RFC for the pipe operator came up. And once I saw it, I started using it wherever I needed compatibility with existing Nix versions. But the biggest problem I see with it is that it's not lazy. What do I mean by that? Let me show an example. So, I'm defining a couple of functions here, f and g, and you can see that whenever they're evaluated, they will print f and g. And when their insides are evaluated, you'll see these strings printed as well, g body and f body. Right, so typical Nix style, if I do f false g null, f is just selecting. Like if it's an optional call. If the condition is true, then it'll evaluate g it'll evaluate this, it'll print the second attribute, second argument, which in this case is an application of G on null. Right, and you can see that it just prints F. Like here, it short circuits, it just sees it as a false, the optionals evaluates to false, so it just prints an empty list. However, if we try to do the same thing with the pipe operator, you can see that it's doing so much more. And this, the biggest place I saw this impact was, there are some flakes where I've got lots of Nix OS machines, and they are kind of generated programmatically by iterating over a list of things. And in those situations, if I have to go into a machine and evaluate a single attribute from that, it'll have to evaluate the entire set of machines for no reason. The pipe operator, the way it's implemented right now, behaves exactly the same as just regular function composition. Right, so no reasons for why a native implementation is needed. Availability everywhere, you don't need to import Nix packages. It's more discoverable because it's a part of the language. It performs better, and the syntax, in my opinion, looks cleaner. The current status of this is that it's implemented in Nix packages as an experimental feature. You can enable it just like Flakes with a flag. And you can use it today in your configs. Now, what do we need from the community? We need real-world usage feedback. We need more people to try it out, discover edge cases, anything that's not accounted for so far, and report back in the RFC thread. And we need community consensus on various design decisions. A bunch of people have just gotten together and made some decisions, including me, and we probably made some mistakes along the way, so feedback is appreciated. I'll just briefly go over some of the design decisions as well. It has lower precedence than function application. So if you do something like, I guess the most significant impact of that is you can't just have in the middle of a pipe x colon x plus 1 or something like that without brackets. It allows natural chaining, and there are two versions, left and right. Personally, I've only used the right apply operator, but there are some people arguing for left as well. Join in on the discussion if you have any opinions on that. Right, so yeah. Yeah. So, one very important design pattern that I've started to rely on with the introduction of pipes is if I've got a long pipe where multiple transformations are being applied and something's breaking in between, I can just stick a trace val in between. So pipe fx, pipe fy, I can just put a pipe trace val in between to see what's being sent from function x to function y. And yeah. So for power users, again, better composition patterns, more maintainable code, reduces parenthesis fatigue. Although, again, that last one might be a me problem more than anything else. Right, comparison with other languages. Lots of other languages have pipes, Bash, of course, we all know. Elixir, F#, OCaml, Elm. I believe Haskell also has a dot operator. And yeah, so extra experimental features, pipe operator, you can REPL it right now on your Nix machines. As long as your Nix is relatively new, it should work. And here's a link. That's a link to the RFC. So try it out, and if you have any thoughts, please join in on the discussion. Anyway, that's the end of that. Thanks everyone. Any questions?